A mirrorless camera begins with molten magnesium alloy, chosen for its strength-to-weight ratio and thermal conductivity. The molten alloy is injected into a precision mold that forms the camera's rigid internal shell.
Once cooled, the raw camera body is released, revealing the skeleton that will house all future components.
CNC machining refines the shell, carving critical surfaces for lens mounts, sensor frames, and structural tolerances.
The machined shell is hand-finished to remove microscopic burrs and ensure flawless ergonomics.
Weather sealing begins with precision-cut rubber gaskets that protect the camera body from dust, moisture, and environmental stress.
Gaskets are installed into millimeter-wide channels that form a continuous environmental barrier. A stainless steel insert reinforces the tripod mount, preventing wear on the magnesium alloy during repeated use. Acoustic and thermal shields are added to control internal noise, vibration, and heat propagation.
EMI shielding ensures stable electronic performance by blocking stray electromagnetic fields inside the camera. Every digital image begins on a pristine silicon wafer, its surface engineered for light conversion with nanometer-level precision. Photolithography etches millions of photodiodes onto the wafer, forming the foundational pixels of the sensor.
Etching sculpts pixel wells that collect photons, transforming light into electrical charge.
Multiple metal layers are deposited to route pixel signals with minimal noise and maximum efficiency.
A color filter array assigns each pixel sensitivity to red, green, or blue wavelengths. Microlenses focus incoming light more efficiently into each pixel, dramatically improving low-light performance.
The wafer is diced into individual sensor dies, each destined to define the visual identity of a camera. Each sensor die is bonded to a ceramic substrate that handles heat dissipation and electrical routing.
An optical stack, UV/IR cut filter, and optional OLPF is mounted to refine the light entering the sensor.
The sensor frame is aligned for perfect perpendicularity to the lens mount, and thermal pads are added for heat control.
The IBIS suspension frame is machined from lightweight alloy to support the sensor with micron-level freedom of movement. Electromagnetic actuators drive sensor movement, enabling stabilization across 5 axes.
Gyro sensors are installed to detect pitch, yaw, roll, and micro vibrations that IBIS must counteract in real time. The shutter curtains are crafted from ultra-thin composite blades, engineered to travel at exceptional speed with minimal distortion. Precise timing ensures the shutter travels at exact speeds, controlling exposure with microsecond accuracy. The sensor module is mounted onto the IBS frame, creating a floating optical platform controlled with micron precision.
Suspension arms are tensioned to balance freedom of movement with precise control across all stabilization axes.
The distance between magnets and coils determines the IBS system's responsiveness and power efficiency.
The shutter unit is mounted above the floating sensor module, requiring perfect parallel alignment to avoid motion artifacts. The IBIS system and shutter must operate in perfect harmony, preventing rolling distortion and ensuring image stability. The main PCB forms the nerve center of the camera, routing power and data through microscopic copper pathways.
The camera's image processor is mounted using thousands of microscopic solder balls that must bond perfectly to ensure high-speed performance.
High-speed DDR memory and non-volatile storage are attached to support rapid burst shooting and video recording. Heat pipes and graphite thermal sheets manage the intense thermal load generated by the processor during continuous shooting and video recording. Flex cables and EMI cages protect high-frequency signals from interference, ensuring clean data transmission through the camera's electronic pathways.
The autofocus module interprets incoming light patterns to accelerate focusing decisions in milliseconds.
Gold-plated lens mount contacts enable high-speed communication between the camera body and attached lenses. Phase detect autofocus pixels embedded on the sensor are calibrated to detect focus direction and magnitude instantly. IBS stabilization is synchronized with autofocus calculations to maintain image sharpness during movement.
The sensor plane must sit perfectly perpendicular to the lens mount to prevent edge softness and focus asymmetry. The electronic viewfinder begins with a micro OLED panel capable of displaying millions of pixels at extreme density.
A collimating lens group magnifies and shapes the micro OLED image into a natural, viewfinder-like scene. The diopter mechanism lets each photographer fine-tune viewfinder focus to match their eyesight. The EVF optical block is aligned so that its image appears perfectly centered and distortion-free when viewed through the eyepiece. The rear LCD panel undergoes inspection for brightness uniformity, color accuracy, and pixel integrity. A capacitive touch layer is bonded to the LCD using an optically clear adhesive that eliminates internal reflections.
The LCD's metal frame and hinge assembly allow precise articulation for shooting at high or low angles.
The rear LCD is mounted onto the camera body, forming the primary interface for framing and settings control.
Touch response and display lag are tested to ensure seamless interaction between user and camera. The EVF and LCD are synchronized with the image processor, completing the camera's visual interface system. Every camera command begins with a tactile switch that must deliver a crisp, reliable click under thousands of presses. The joystick provides precise focus point control, its microsensors reading pressure from multiple angles.
The command dial clicks through exposure adjustments using a ratchet system with highly controlled resistance.
The mode dial's locking button prevents accidental changes, combining mechanical precision with ergonomic design. The rubber grip is bonded to the magnesium body using heat-activated adhesive for durability under all weather conditions.
The shutter button's two-stage mechanism allows half-press focusing and full-press shutter release with precise tactile separation. Rear buttons and rotating wheels complete the camera's manual control system, enabling rapid on-the-fly adjustments.
Programmable function buttons receive gold-plated contacts to ensure long-term reliability and weather resistance.
Ergonomics testing ensures every button sits exactly where a photographer's fingers naturally fall.
Each switch undergoes durability testing to verify consistent tactile feel across tens of thousands of presses. The lens mount base provides structural rigidity, ensuring that every lens aligns perfectly with the sensor.
A stainless steel ring is added to the mount for durability, ensuring lenses attach securely over years of use. The flange distance is calibrated to ensure precise focus performance across all lenses. Mount rigidity is tested to ensure the structure does not flex, even with heavy telephoto lenses attached.
Electrical contacts are tested for signal integrity, ensuring high-speed communication between lens and camera.
A rubber weather seal is added around the mount to protect against dust, moisture, and harsh outdoor conditions. An optical collimation test ensures that light entering the mount reaches the sensor in a perfectly aligned path. The internal chamber is checked for unwanted reflections that can cause flares or contrast loss.
Parallelism between the sensor and mount ensures sharpness consistency across the entire frame.
The mount is subjected to controlled thermal cycling to ensure it maintains alignment under temperature changes.
The top plate houses critical controls and must fit the chassis with perfect mechanical alignment.
The bottom plate provides rigidity and integrates the tripod interface with reinforced structural support. IAO ports are installed with EMI shielding to ensure clean, high-bandwidth signal transmission.
Steel reinforcement brackets prevent port wear and ensure long-term durability when cables are repeatedly plugged and unplugged.
The dual SD card slot uses precision spring-loaded mechanisms to secure cards with perfect insertion force.
Internal flex cables are routed through narrow channels to maintain signal integrity and avoid mechanical strain.
Adhesive strips and microclips secure cable paths, preventing vibration and long-term fatigue.
The battery chamber is reinforced to protect internal wiring and ensure a secure electrical interface. Rear weather seals protect the internal wiring and ports from moisture and dust intrusion.
A dust and vibration shield protects delicate cables from long-term mechanical stress. The camera's side panels are attached to complete the structural shell and protect internal wiring. Cooling ducts channel heat away from the processor and sensor during extended shooting sessions. A compact resonance chamber enhances speaker clarity while minimizing vibration transfer to internal components.
Microphone mesh and wind filters control airflow and reduce noise for high-quality audio capture.
Port doors receive rubberized weather gaskets to protect against rain, dust, and extreme humidity.
Every structural screw is torque tested to ensure long-term durability and resistance to vibration. The hot shoe provides both mechanical support and high-speed data communication for external accessories. The camera is powered on for the first time, verifying that all systems initialize correctly.
Every button and dial is tested for responsiveness, ensuring precise user input with no lag.
A final structural integrity check ensures the assembled body can endure real-world handling and stress.
Firmware activates the camera's intelligence, linking sensor, processor, stabilization, and autofocus into one cohesive system.
Sensor calibration removes fixed pattern noise and maps pixel behavior for consistent image quality.
Color science calibration ensures accurate, natural tones across diverse lighting conditions.
Autofocus accuracy is tuned to ensure rapid, reliable subject detection and tracking performance.
IBS stabilization is tuned so the sensor floats with precise, controlled motion to counteract camera shake.
Shutter travel speed is measured precisely to prevent exposure inconsistencies and distortion. Rolling shutter evaluation tests how the sensor readout handles fast motion without skewing or wobble.
The camera's dynamic range is measured by exposing it to extreme contrast scenes to evaluate highlight and shadow recovery.
Low-light testing ensures the sensor maintains detail and minimizes noise at high ISO levels.
A full image pipeline check confirms that sensor, processor, stabilization, autofocus, and display systems operate flawlessly together.
The rear cover seals the camera's electronics and completes the body's structural integrity.
The eye cup provides comfort and blocks stray light, shaping the shooting experience.
Accessory covers protect sensitive terminals from dust and moisture, preserving camera longevity.
Branding plates and logo badges are applied with absolute alignment for a premium finish.
Decorative bezel rings and grip textures complete the camera's ergonomic and aesthetic design.
Every camera is meticulously cleaned to ensure no dust or fingerprints reach the customer. A full system test verifies flawless communication between every component inside the camera. Shutter lifecycle testing ensures long-term reliability across hundreds of thousands of actuations. The IBIS system is tested for long-term durability through extended vibration and motion cycles.
Autofocus tracking is pushed to its limits against fast, unpredictable motion.
The mechanical heartbeat of the camera is revealed in a sweeping cinematic view.
The sensor's microscopic architecture glistens under the shifting light.
The finished body reflects craftsmanship in every angle and contour.
The camera lights up with dual displays, working in perfect harmony.
Hundreds of finished cameras stand ready, each crafted with precision and care.
Protective packaging is cut with precision to cradle each camera during transport.
The camera settles into its final resting place before meeting its future photographer.
Protective films and accessories complete the package with meticulous attention to detail.
A final seal certifies that the camera has passed every test in its creation journey.
From raw metal to a precision instrument, the camera is ready to capture the world.